All right, gentle people. As promised, we're supposed to be looking at the sum and product of roots, and we're going to practice working on some of these questions and what they actually look like when you're in an exam, how they'll probably structure the question. All right, so here's the first one. Straight into it. The quadratic equation x squared minus 4x plus 6 is equal to 0, and it has roots alpha plus beta. Calculate the value of alpha squared plus beta squared. All right, so this is not just finding alpha or beta, right? But that will help us to find alpha squared plus beta squared. Now, the important thing to note or to recognize is that alpha squared plus beta squared is a part of an expansion. All right, which expansion you might ask? If I look at, and let me get this pencil working, of course. The second I switch to this thing, this pencil won't work. All right, let me put that dot on here somewhere. All right, we're good to go. All right, so if I look at alpha plus beta all squared, I'll know that this is alpha plus beta times alpha plus beta. You're aware, but just so you can see the expansion, it's going to be alpha times alpha, alpha squared, alpha times beta, alpha beta, beta times alpha, which is beta alpha, still alpha beta, because the order of multiplication doesn't matter. Multiplication is commutative. And then beta times beta, which is going to be beta squared. Now, what you'll notice is what we want is right here and right here, all right? So what we're looking for is alpha squared plus that beta squared, and what's left is going to be 2 alpha beta, all right? Just adding these two terms here. Now, if that's the case, let's put this a bit in more perspective if we can, all right? Let me see. I need to write x squared minus 4x plus 6, right? Then I can say effectively that alpha plus beta all squared is this thing that I want, this section here, plus this, all right? Which means that this thing that I want, if I make that the subject of my equation, all right, is the same thing as alpha plus beta all squared minus 2 alpha beta. So this is really what I'm going to find, because if I can find the sum of roots here and the product of roots, I have found the answer I'm looking for. So, because my memory is horrible, it's x squared minus 4x plus 6, right? If x squared minus 4x plus 6 is equal to 0, then we can find our sum of roots, because remember, your alpha plus beta is going to be equal to negative b over a, while your alpha beta is going to be equal to c over a. So negative b is going to be the negative of negative 4 over a, which is 1. Negative times negative, positive. I'm going to get 4 here. And my alpha beta is just going to be c over a, which is 6 over 1, or 6. So we're pretty much done there now. It's almost done. We're going to end up with, if I can shift this up a little bit, all right, we should have alpha squared plus beta squared being equal to alpha plus beta all squared minus 2 alpha beta. And this is going to be 4 squared minus 2 times 6. I really don't want to shift this up a little bit more, but I need you to see this in full. We're almost there. It's almost done. 16 minus 12, or 4. All right. So this would be our answer. I can't remember exactly how many marks this was. Let's take a look as to how many marks this was. It's 5 marks, and you're likely going to get marks for making the connection here between alpha plus beta all squared and alpha squared plus beta squared. And then, of course, for finding each of the sum of roots and product of roots. And then from there, making the substitutions and maybe 1 mark for your answer. All right, so not too bad, not too tricky. We know what that looks like now, and if we get a question that looks like this, we should be okay to solve it. All right, next one, real quick. All right, so this one says the equation 3x squared minus 6x minus 4 is equal to 0. Has roots alpha and beta. Fine. Find the value of 1 over alpha plus 1 over beta. Now, as was the case before, start here. What does this really equate to in terms of alpha plus beta and alpha beta, the sum of roots and the product of roots. So if I look at 1 over alpha, this is my alpha. You know you love my handwriting. Plus 1 over beta. If I want to add these two things, I'm going to have a common denominator, right? Now, I can draw the line here. I don't know how comfortable you all are, but what I want to do, I don't want to do this. I want to draw the line. I want to not sing that song that we all sing and the teachers have us sing when we're adding fractions, right? I am, let me erase that. I am going to look at this as an operation in equivalent fractions where I want both of these things to have the same denominator. So what I would do is I'm going to say that this is something over alpha beta plus something over alpha beta, right? Because both alpha and beta can go into alpha beta. Now, for the first term, in order for the denominator not to be alpha and for it to be alpha beta, I'd have to multiply this by beta, right? And if I multiply the denominator by a term to retain the value of that term, I must multiply the numerator by said term. So this becomes beta over alpha beta. So 1 over alpha is the same thing as beta over alpha beta. Likewise, if I'm adding to it something over beta, 1 over beta rather, and I want to express it as something over alpha beta, I'd have to multiply this beta by alpha to make the denominator alpha beta, and now I have to, of course, multiply the numerator also by alpha, and I end up with alpha over alpha beta. Now, your question is, what's happening? Well, we can add it now, right? The denominators are the same. That's how fractions work. And if the denominators are the same, I can now write this as, one single term with a denominator of alpha beta, and I can add the numerators. So I can add beta plus alpha, or effectively alpha plus beta, sum of roots over product of roots, right? That's what this is equal to. So now the question is, can we find the sum of roots and the product of roots? Trying not to kick this device's cord out. All right, so let's shift this down a little bit. All right, so I have 3x squared minus 6x minus 4. Let me shift this up. So 3x squared minus 6x minus 4 is equal to 0. And even though I said it out loud, I'm checking again. Better to be safe than sorry. Minus 6x minus 4. Looks like we're good, right? Now, what is sum of roots? Sum of roots, as I said before, is negative b over a. Product of roots is just going to be c over a. What's b? Well, b is negative 6. So this is negative 6 over 3. And c would be negative 4 over 3. So what do we end up with? Negative times negative positive 6 over 3, or just 2. And over here we have negative 4 over 3. So what does that mean for our final answer, right? We need to have alpha plus beta over alpha beta. So alpha plus beta sum of roots over alpha beta is really going to be equal to, what's the sum of roots here? 2 over or divided by negative 4 over 3. Same thing as 2 over 1. And if you divide by any term, it's the same as multiplying by its reciprocal or its inverse. So instead of negative 4 over 3, I could have 3 over negative 4 or negative 3/4, depending on how you want to write that. All right, almost there. We can divide this through by 2 to give us 1, divide this through by 2 to give us negative 2. We'll end up with 3 over negative 2. Positive divided by a negative means that the whole term itself is negative, or negative 3 over 2. And we're done with this one. So there's not many ways that this thing can be done in terms of how they'd ask this question. This is easy marks for you. And speaking of marks, how many marks would you have gotten for this? Maybe 3, I think. 4 if they're generous. Oh, it's a 4-mark question. So very generous on this one. And I think the final one is very similar to this one. So we literally can just jump into it. This one reads the quadratic equation 2x squared plus 6x plus 7 is equal to 0. And it has roots alpha and beta. You need to calculate the value of 1 over alpha plus 1 over beta. Now, we have the benefit of having just done this, right? So 1 over alpha plus 1 over beta, you're going to work it out to get, we can say 1 over alpha plus 1 over beta. You would work this out. Do not jump to this step. You'll likely miss a mark because there's no way that the examiner is just going to set you is going to see you just jump to this step and go, oh, this person just knows it. Even if you do, please show the working, right? Add the 1 over alpha to the 1 over beta to give you alpha plus beta over alpha beta. Please. Thank you. All right, so what's our sum of roots, right? Based on the equation, our sum of roots is negative b over a, which is going to be here. What's b here? It's going to be negative of 6 over 2. And alpha beta would have been, what is it? Just c over a, or what looks like 7 over 2. So what does this look like, right? We can do this quickly. This one is a quick one. And this was 4 marks as well, so you do need to do that step, please. I appreciate you. So this would have just been negative 3. And so 1 over alpha plus 1 over beta is going to be alpha plus beta, which we said is negative 3 over 1 divided by alpha beta, which is 7 over 2. Negative 3 over 1 times 2 over 7. And we're just going to go over here. And that's going to be equal to what looks like, since we can't cancel here, we'll just multiply across numerator by numerator, which is going to be negative 6 over 1 times 7, which is just 7. And again, positive, sorry, negative term divided by positive means the whole thing is negative. No, you don't have to. This is fine. Everybody's comfortable with that. So, all right. So these are 3 examples. First one was worth 5 marks. So the latter 2 were worth 4. It's easy. It's easy work. It's light work for you. These are marks that you can pick up really quickly once you understand the concept. Again, I owe you a worksheet on this, so that's coming out. Probably in the next couple of minutes, I'll have a worksheet out on this for you to practice. And I'd expect that by now, we've pretty much finished quadratics. I'll check to see if there's anything I've missed. But if we're finished with quadratics, I'll just do a summary final paper in terms of questions that we can practice and answer. So in the next video, we're definitely going to likely be wrapping up with quadratics and the questions that you can see. And I'll do a walkthrough just like this one. But expect a worksheet today. And again, as always, this helps us to grow. Don't forget to like and share. Have a great one, people. See you in the next video.